Okay, right. And now we are going to start sequences in this mathematics session. Sequence. What is basically a sequence? To discuss, sequence is nothing but an ordered set of objects. What I am going to mention you is sequence is nothing but ordered set of objects. Right? See, objects, mathematically objects means every living or non-living thing. See, usually numbers we consider as objects. Not only numbers, sometimes alphabets or some objects also, like living or non-living items also, things also we consider as objects mathematically, right? So objects means numbers or alphabets or any living or non-living things which under consideration are known as the objects, right? And that set of objects, if they have an importance for the order, we call them as ordered set of objects. That ordered set of objects is basically mentioned as the sequence, right? I am repeating here, you need to concentrate on the term that ordered set of objects. Since there is an order for the set of objects, it is easy for all of us to identify the first object, second object, third object, like that. If there is no order for this set, if there is no order for certain set of objects, then you can't identify the fourth object from that set. You can't identify the 10th object from that set because there is no order for that. Since they are in irregular manner, you can't identify the fourth object or fifth object like that. But since there is an order for the considered set of objects, then it is easy for all of us to identify the first object is this, second object is this, third object is this. Like that, it is very easy for all of us to identify. So sequence is basically an ordered set of objects. Here there is an importance, a full importance for the term order. Because of that term, that order, now it is easy for all of us to identify first object, second object, third object, like that. If you have a sequence, if anybody asks you to identify the 10th object, then you are able to identify the 10th object, right? And if you have a sequence of objects, and I will show you one object, and I am asking you the position of object, then you are ready to answer the position of the object if only the elements, the objects are in the sequence. Once again I am repeating, see, if you have certain objects and if you maintain an order for the objects, then those ordered set of objects is mentioned as a sequence. In other way, see, objects, in another way what I am going to tell you is objects of the sequence will maintain one-to-one correspondence. One-to-one correspondence with the natural numbers. I think you know about the counting numbers, right? Nothing but natural numbers. If there is a one-to-one correspondence with the natural numbers, then that collection is mentioned as the sequence. Both are same actually, right? See, one-to-one correspondence with the natural numbers means for natural number 1, you have a corresponding object there. For natural number 2, we have a corresponding object there. For natural number 3, we have a corresponding object there. So this type of matching, tallying is nothing but the one-to-one correspondence. For example, your roll numbers of your class. See, for roll number 1 is one particular person. Roll number 2 is one particular person. So roll numbers of the class, see, if the persons are in roll number wise, then that set of objects, then the collection of the people are mentioned as usually a sequence if they are in roll number order. If they are not in roll number order, if they stand in irregular manner, then we don't consider it as a sequence because we don't know who is the first, who is the second if they are in regular, right? Similar to this, if few people are standing in a queue, maybe for tickets in railway station or maybe in cinema theater like that, if there are few persons stand in a queue, that queue is an example for the sequence. Because if you observe that queue, it is easy for all of us to identify the first person of the queue, the second person of the queue, the 10th person of the queue. It is easy for all of us to identify. Since there is a correspondence with the natural numbers for the persons who are standing in the queue, person standing in a queue is an example for the sequence. For suppose, if my friend is there in the queue, you may say it as Mr. X. See, Mr. X, my friend, is there in a queue, If anybody asks you what is the position of Mr. X who is standing in the queue, see, I am giving you the person, then by observing the queue you may say that he is at the sixth position, he is the sixth person of the queue, like that you will say. See, that is the sense. If I give you a person, then you are able to give me the position, right? If I give you a position, then it is easy for you to identify the person. That means person represent the position, whereas the position represent the person. If there is such tallying for the persons to the position, then that is usually mentioned as the sequence. If you don't have that tallying, then we don't call it as a sequence. For example, there are few persons for the collection of tickets, but they are not in a queue. They stand in a irregular manner, so we don't call it as a sequence. Because since the states stand in an irregular manner, we are not able to identify the first person of the queue, or we can't identify the third person of this collection, so we don't call it as a sequence. So basically what I am going to tell you is, sequence is nothing but an ordered set of objects. We have a set of objects and there is an order for the set of objects. Since there is an order for the set of objects, the terms of the sequence is usually mentioned as T1, T2, T3, T4, like that. Or otherwise in some books they may maintain A1, A2, A3, A4, A5, like that for the terms of the sequence. See, there are different types of sequences. Some sequences are finite sequences, maybe the persons of the queue. Maybe you may have some 15 to 20 persons in that queue. Finite sequences. And there are some sequences which are infinite, like the natural numbers. Natural numbers itself is a sequence, because we are able to identify the first object of the natural numbers, which is 1. If anybody asks you what is the 100th object of the natural numbers, clearly 100. And I will give you a number like 150. What is the position of the number 150? It is easy for you to identify the position of the number as again 150. So we are able to identify the position versus the person. So the natural numbers is also an example for the sequence. And the elements of the sequence are usually termed as T1, T2, T3, T4, like that, as well as A1, A2, A3, A4, like that. And I will give you few examples for the sequences. You just think about few examples and I will mention you all the examples now. See, from your previous knowledge, I think you are well known about the arithmetic sequence, and few people may know about the geometric sequence, like that. But not only those, we have many sequences. I will give you examples for all those things. Just have a look. For example, I have numbers like this: 2, 4, 6, 8, 10, and so on. See, I will call it as a sequence of even numbers. Is it right? A sequence of even numbers. For example, if I have like this: 2, 3, 5, 7, 11, 13, like that. If I proceed, I may call it as sequence of prime numbers. Prime numbers are also in sequence. Why? Because, see, what is the first prime number? 2. What is the fifth prime number? I will count 1, 2, 3, 4, 5. This is the fifth prime number. Right? If anybody asks you what is the 25th prime number, so I know it the 25th prime number as 97. So see, the sequence of primes, see, these prime numbers are also mentioned as a sequence. And if I move, see, I may consider different sequences, right? For example, I have 1, 4, 9, 16, 25, like that. You may call it as sequence of perfect squares. Right? See, I am able to identify the position. If anybody asks you what is the position of 10,000, see, 10,000 is 100 square, then the position of 10,000 is 100. So object is 10,000, its position is 100. We are able to confirm that. So it is a sequence. If it is not possible, we don't call it as a sequence. Right? I will give you a few examples like this. For example, I have a sequence like this: 0, 1, 0, 1, 0, 1, 0, 1, like that. See, this is known as usually oscillating sequence, because the numbers 0, 1 are oscillating here, right? So we call it as an oscillating sequence. Here also, if what is the object in thousandth place. If anybody asks you, give me the object in the thousandth place. See, if you observe, first place 0, second place 1, third place 0, fourth place 1. That means every even position occupied by 1 and odd position occupied by 0. So what is the element in the thousand place? Clearly it is 1. What is the element in the 2019th place? Clearly it is 0. So along with the position, I am able to give you the object. So we call it as an oscillating sequence. For example, if anybody asks you, what is the position of 0? Right, object is given and they are asking you the position. See, if anybody asks you to identify the position of 0, there are many positions for 0, so you may say some positions. You are able to give you the position, right? So that's why you are calling it as a sequence. Since 0 1 0 1 0 1 are repeating here, we call it as an oscillating sequence. For example, I have this 3 square is 9, and then 27, and then 81, and then 243, like that. We call it as sequence of powers of 3. Sequence of powers of 3. This is 1, this is 2, this is 3, this is 4, this is 5. Like that, we have a correspondence with the natural numbers. That's why we call it as sequence of the powers of 3. So, like in this manner, if you think, there are many sequences. What I am going to tell you is, there are many sequences. Sequences of the multiples of 3. Sequences of the odd numbers. Right? Sequences of the factors of 12. Sequences of the products of two consecutive numbers. Oscillating sequence. Finite sequence. Infinite sequence. Natural numbers itself is a sequence. So there are many sequences. Like sequence of even numbers, sequence of prime numbers, sequence of perfect squares, oscillating sequence, sequence of powers of 3. Like that, there are many sequences. Among these sequences, there are some special sequences which are frequently utilized. Frequently we will use some sequences in our regular day-to-day life and in our regular problems. And those special sequences are usually arithmetic sequences and then geometric sequences along with the harmonic sequence. Right? We are going to discuss all those things. So, but just right now, we need to know about the sequence. Sequence is nothing but the set of objects if they have an order, right? And those elements of the sequence are usually denoted by T1, T2, T3, T4, T5, like that. Or some may indicate by A1, A2, A3 also. For example, I have sequence of perfect square. What is T100 of this sequence? T100 is 100 square, right? What is, you may say, T10 of this sequence? T10 is 20 for this sequence. Like that we are able to mention, right? So these are few examples for sequences. Just have a look, right? And then we are going to identify a special property of these sequences. With that specialty, we will classify these sequences as like arithmetic sequence or like geometric sequence. We may call it as progression also. I will confirm afterwards, right? And right now, I have a problem to discuss with you. Just have a look here. I will give you the problem regarding these sequences. I am erasing this. See, there are few problems related to these sequences also, right? The problem what I have in my hands is, see, there is a sequence. See, usually sequence is denoted by like this or otherwise like this. That means there is a sequence whose terms are T1, T2, T3, T4, like that. See, this is a sequence with the first term of the sequence as 3 by 8. What I mentioned you, the first term of the sequence as 3 by 8, and Tn is usually mentioned as 1 plus Tn minus 1 divided by 1 plus, see, 1 minus Tn minus 1. Have a look here. See, I have Tn which is 1 plus Tn minus 1 divided by 1 minus Tn minus 1. Then you need to identify what the 2020th term of this sequence. Just have a look. Once I will explain you the question and then I will leave you a fraction of seconds to try in your own way. After that, I am going to discuss the solution right now here. See, there is a sequence. The sequence may consist of many numbers, and for that sequence, the first number is 3 by 8, right? And the sequence follows a particular rule, right? What the rule? Tn is equals to 1 plus Tn minus 1 by 1 minus Tn minus 1. See, every sequence, sometimes it may have a rule. For example, sequence of perfect squares. The rule is what? N square. 1 square, 2 square, 3 square, like that. Sequence of even numbers. What is the rule? 2 into 1, 2 into 2, like that. But there is no rule for the sequence of primes. Is it right? See, the sequence, there is no compulsion for the maintaining a rule. Sometimes there is a rule, sometimes we can't identify a rule, right? Now, see, I have a sequence and that sequence is maintaining a rule that Tn is equals to 1 plus Tn minus 1 by 1 minus Tn minus 1. And they are asking you to find the 2020th term. Only the first term is mentioned and they are asking you to find 2020th term, which is following this particular rule, right? First of all, we have the first term. So you just try to find few terms of the sequence and then proceed. After that, you have a clear idea which is the 2020th term. So I am going to find the second term of the sequence. See, according to this rule, you just look at this rule. I need the second term because already first term is there. See, for the second term, you just take n is equals to 2, right? See, if n is equals to 2, T2 is equals to 1 plus T2 minus 1, it's before term, divided by 1 minus T1. This rule suggesting us that every term is 1 plus its before term divided by 1 minus its before term. So with that idea, this T2 is 1 plus T1 by 1 minus T1. 1 plus T1 is what? 3 by 8. 1 minus T1 is nothing but 1 minus 3 by 8. And if you simplify, I think you are confident about the fractions. If you simplify, 8 plus 3 is 11 and 8 minus 3 is 5. So the second term of the sequence is 11 by 5. I think everything is clear. See, the first term is given as 3 by 8. With this rule, I found the second term as 11 by 5. And now, I am going to identify the third term. See, the third term is given by 1 plus T2 by 1 minus T2. As per the given rule, every term is 1 plus its before term by 1 minus its before term. And this is equals to 1 plus, what is T2? 11 by 5. You just replace T2 with 11 by 5. 1 plus 11 by 5, 1 minus 11 by 5. I need to simplify. So if I move for the simplification, this is, see what it is, 5 plus 11, 16 divided by 5 minus 11, minus 6. I am directly writing it as 5 plus 11 by 5 minus 11, 6 by 16 by minus 6. So if you do with cancellation, this is minus 8 by 3. I am finding few terms of the sequence to identify a pattern, right? The first term is given as 3 by 8. The second term is 11 by 5. And the third term is minus 3 by 8. Now I am going to find the fourth term again. Yeah. See now, what is the fourth term of the sequence? See, the fourth term is again 1 plus T3 by 1 minus T3, right? So 1 plus T3 means what it is here? Minus 8 by 3. And 1 minus T3, that means 1 minus of minus 8 by 3. If you simplify, see, directly I am writing 3 minus 8 is minus 5, 3 plus 8 is 11. And this is the fourth term. Just have a look. First term is given as 3 by 8. Second term is 11 by 5. Third term is minus 8 by 3. And fourth term is minus 5 by 11. Then what is T5? Fifth term. Again use the same trick. What it is? T5 is 1 plus T4 by 1 minus T4. And that is equals to 1 plus T4 is what? Minus 5 by 11. T4 is what? Minus 5 by 11. And if you simplify, you will get it as 11 minus 5 by 11 plus 5. And that is equals to 6 by 16, which is nothing but again 3 by 8. Just have a look. Yeah, after this lengthy simplification by term, see again I have that fifth term as 3 by 8 only. Right? Since the fifth term is 3 by 8, then automatically what is my sixth term? 11 by 5. What is my seventh term? Minus 8 by 3. What is my ninth term? Like that, if you proceed, all the terms will repeat it like that, no? So, at the end, I have a conclusion that this sequence is an oscillating sequence with the 4 elements, right? See, the rule is same. 1 plus its before term by 1 minus its before term. So, if T5 is 3 by 8, to find T6, 1 plus 3 by 8 by 1 minus 3 by 8. Like this, you need to proceed. Again, you will get that 11 by 5 only. Okay, now. So, with these terms, if you maintain a sequence, every fifth term, after that fourth term, you will again start with 3 by 8 only. Is it clear? Just think wisely. Have a look at this problem, right? See, I am counting few terms of the sequence starting from the T1. So I need to list out those sequences at the end for you. See, if I list out all those elements of the sequence, they will look like here. I am erasing this space. I am utilizing this. Now at the end, what I have in my hands is, see, this one. The first term is 3 by 8. The second term is 11 by 5. The third term is minus 8 by 3. And then the fourth term is minus 5 by 11. And then the fifth term is 3 by 8. Since it is 3 by 8, the next term is 11 by 5. The next term is minus 8 by 3. The next term is minus 5 by 11. We will continue like that. And this is your sequence at the end in your hands. See, if you observe the sequence, first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. See, after every 4 terms, again the elements are oscillating. Right? I think you are identifying it. And that in the sense, 4th term, 8th term, 12th term, 16th term, like that. Every time you have that minus 5 by 11 as your element. So here this 2020 is also a 4 multiple. So your answer for this question, 2020th term of this sequence is minus 5 by 11. Right? See, just have a look here. See, actually this is the first class of sequences. There are we don't have many problems regarding the sequences. See, after this sequence I am going to enter into arithmetic sequence, geometric sequence, like that. We have many problems in arithmetic sequence. Just to discuss with you how the problems are there in sequences, I just mentioned one problem here. This is the just one problem about the sequences. Don't worry if you have any confusion regarding this. Right? As I told you, a sequence maintains an order among the elements. See, the first element is given and they gave a rule to find the other elements. With the support of that rule, my second element, third element, fourth element, fifth element. Fifth element is again the first element. That in the sense, the sequence is following an oscillating pattern after every 4 elements. That means, have a look at the fourth element. Every fourth element is same as minus 5 by 11. Fourth element, 8th element, 12th element, 16th element, like that. Every 4 multiple is same as minus 5 by 11. And now my question is to find 2020. This is also 4 multiple. So my answer for the question is again minus 5 by 11. So answer for this question is minus 5 by 11. Just have a look. Go with a screenshot right now. Right? We have a problem on the board that a sequence which is repeating after every 3 terms, like 178, 178, 178, like that. This 8 is a third position, 6th position, 9th position, like that. If anybody asks you to find 2020th term, since this 2020 is not a multiple of 3, you need to look at the multiple of 3 nearer to this 2020. 2019 is clearly a 3 multiple. So every third 3 multiple term is 8. So T 2019 is also 8. Automatically its next term is 1 since the sequence is repeating. Right? This is something about the sequence. Right? And now there are different sequences, as I mentioned you before this, like sequences of primes, sequences of even, sequences of natural, sequences of perfect squares, like that. Among those, there are few sequences in which there is a rule from one term to the other. See, what I am going to tell you is sequences versus progressions. Sequences versus progressions. That's what I am going to discuss. Progressions are nothing but sequences only. Right? Which type of sequences they are means there is a specific fixed rule followed by every consecutive terms. That in the sense, if every term of the sequence is generated by its previous term following one particular rule is known as the progression. Right? I think the definition is clear. Once again I am repeating, progressions are also sequences. Some special sequences are known as progressions. That speciality is, in these progressions, in these sequences, every term is generated by the first term with one specific rule, right? With one specific pattern. There is a constant relation between the consecutive terms of the sequence. If there is a consecutive, there is a specific relation between the consecutive terms, then we call it as a progression, or otherwise we just call it as a sequence. I will give you one example like this. For example, see 1, 4, 9, 16, 25 and so on. These are the sequence of perfect squares. Whereas if you mention like this, something like 3, 6, 9, 12, 18 and so on. Or otherwise 2, 4, 8, 16, 32 and so on. See, just look at this. You don't have a specific relation from one term to the other in this sequence. This is a sequence, but it is not a progression. This is a sequence, but it is not a progression. But whereas if you think about this case, this is clearly a sequence and progression also. Every progression is again sequence, but few sequences are only progressions. To say it as a progression, you need to maintain a constant relation between the consecutive terms. That in the sense, here we are maintaining a common difference concept. 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3. Right, I need to write it as 15, right? So, 3, 6, 9, 12 and 15. 3 like that. And now, 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32. Like that, if we move, we call it as progressions. So these are examples for progressions, and this is an example for sequence which is not progression. And then what I am going to conclude you is, sequence means ordered set of objects. Progressions means a special type of sequences in which there is a constant relation between the consecutive terms. Right? And every progression is a sequence, but every sequence need not be a progression. This is an example, sequence of perfect squares. It is a sequence, but it is not progression. We don't get we don't have a perfect rule between the consecutive terms. We have a rule for this sequence as n square. See, for example, if anybody asks you to identify, see, some seventh term, directly use 7 square, but you don't need its before term, right? So we don't have such a chance to generate 7th term from the 6th term. So we call it as just a sequence, not progression. But whereas here, if anybody asks you to find the next term, you are adding just 3. That means here we have a chance to generate the next term from its previous term. So these are examples for progressions as well as sequences. This is just a sequence but not progression. Right? Just have a look. So we may call them as progressions as well as sequences also. In some books, there is a chapter named sequences. In some books, there is a chapter named progressions. Both are basically same, right? And among these progressions, if there is a constant difference between the terms, we call it as arithmetic progression. That's why usually we call it as arithmetic progression. Arithmetic progression or sequence. And if there is a constant ratio between the consecutive terms, we call it as geometric progression or sequence. So, sometimes and some books may mention it as arithmetic sequence, and some books may call it as geometric sequence, and sometimes geometric progression, arithmetic progression. So this is somewhat about the progression and sequence, and this is the basic examples for arithmetic sequence and geometric sequence. Have a look, and I am going to start arithmetic sequences or arithmetic progressions. Have a look. Go with a screenshot. See, this is all something about the conceptual ideas of sequences and progressions. But to solve the problems, you need formulas related to these sequences, and starting from the arithmetic sequence, we have such formulae. Now, we have to discuss about the arithmetic sequence. As per the definition, arithmetic progression or arithmetic sequence is a sequence or progression in which there is a constant difference between the consecutive terms, right? Just have a look. Arithmetic sequences. See, for arithmetic sequence, if we have few terms in the sequence like T1, T2, T3, T4, like that. If this is arithmetic sequence or arithmetic progression, you may use it as arithmetic progression like AP. See, if they are in arithmetic progression, only if the difference between the consecutive terms is constant, that in the sense T2 minus T1 is equals to T3 minus T2 is equals to T4 minus T3 is equals to, and so on. If you continue like that, if there is a constant difference between the consecutive terms, then only we will say it as arithmetic progression, and you just represent the constant difference by D, and we usually call it as common difference of the arithmetic progression. I think you are all aware about this arithmetic sequence, but I am going to handle this arithmetic sequence in my way, right? See, T1, T2, T3, T4 are arithmetic progression. If there is a common difference between the consecutive terms, that means difference between T2 and T1, difference between T3 and T2, difference between T4 and T3. If such difference is this D as common difference, and that sequence as an arithmetic progression. And now what I am going to tell you is, you just let first term as A. We are going to develop certain theory related to the arithmetic progression, few formulas related to the arithmetic progression. To develop such concepts, such formulae, we need to let the first term is equals to A of this arithmetic progression. And at the end, what I have in my hands, I have a first term of the arithmetic progression as A and the common difference of the arithmetic progression as D. Using these two, I am going to generate the arithmetic progression now. See, what is the arithmetic progression actually? T1, T2, T3, T4, T5, like that. Now what is the first term? As per my supposition, the first term is A. Since the first term is A, what you say about the second term? See, the second term minus first term is the common difference T. Have a look at this. See, if you replace this first term by A, T2 minus A is equals to D, then you will get the second term as A plus D. Have a look at this. The difference between second term and the first term, we need to maintain it as D. If you take the difference, it is clearly D, right? So the difference is D, so the second term is A plus D. If you proceed in such a manner, every time you need to add one D to get the second term. Next term, so this is A plus D, next term is A plus 2D. Then your fourth term is A plus 3D, and your fifth term is A plus 4D. If you continue like that, you need to identify the nth term of this arithmetic progression, right? See, first term is A, for the second term this is 1D, third term it is 2D, fourth term it is 3D, so for 4 it is 3, for 5 it is 4, so for n it is A plus n minus 1 into D. So at the end, what we have in our hands is D. There is an arithmetic progression whose first term is A, common difference is D, then for that arithmetic progression, nth term is A plus n minus 1 into D. We also call it as general term or nth term of the arithmetic progression. With this idea, we are able to identify the nth term of different arithmetic progressions, right? Just have a look at this and go with the screenshot. I will discuss a few simple problems related to this arithmetic sequence based on this nth term, right? Just have a look. Yeah, I am going to give you the problem. I think you are aware about this arithmetic sequence, but as a revision, just go with this arithmetic sequence. Within 2 days, we will start the geometric sequence again, right? See, for example, I have a problem. For that problem, T7, see, there is an arithmetic progression. In that arithmetic progression, T7 is given as some 31, right? And T10 is given as 43. And they are asking you to find T18. Just have a look at this problem. I have an arithmetic progression whose 7th term is 31, whose 10th term is 43, and now it is our part to find the 18th term of the sequence. See, I have a rule for the nth term of the arithmetic progression. I don't know the first term of this arithmetic progression. Let it as A. I don't know the common difference of this arithmetic progression. Take it as D. If first term is A and common difference is D, then the seventh term of this arithmetic progression is A plus 6D as per the rule. Just have a look. Seventh term is 60, right? The nth term. Then the 10th term is given by the rule that A plus 9D and it is given as 43. Now in my hands I have the seventh term A plus 60, 10th term A plus 90 as 31 and 43, and now I wish to find 18th term. See, T18 is nothing but A plus 17D. Every time you need to reduce this number by 1 to write like this. And now to find this 18th term, it is enough to find A and D. So how to find A and D? There are two relations based on A and D and we need two variables A and D. Just simplify that. If you do subtraction, this A and A will get cancelled. 6 minus 9 minus 3D, 31 minus 43 made it 12, minus 12. Is it right? And now from this D is equals to 4. So the common difference of the problem is 4. Since the common difference is 4, use that 4 here to get A. Then how you will get A? Then A is equals to, I am directly writing here, since D is 4, this is 24. 31 minus 24, which is nothing but 7. Is it clear? So at the end, I have A is equals to 7 and D is equals to 4 to find the 18th term. And that 18th term is given by A plus 17D. So A plus 17 times of 4. This is equals to 7 plus 17, 4 maybe 68, I think, if I am right. And 67 plus 8 is nothing but 75. At the end, 18th term of this given arithmetic progression is 75. Just have a look. Once again I am repeating, the problem is asking you to find the 18th term of an arithmetic progression where the 7th term and the 10th term are given as 31 and 43. Based on this, you need to find this 18th term. To find 18th term, our idea of 18th term is A plus 17D with the general term formula. So to find 18th term, you need A and D. So for that, use 7th term as A plus 6D is equals to 31. 10th term as A plus 9D is equals to 43. If you do subtraction, you will reach that D is equals to 4. Using this D in these equations, you have that A is equals to 7. Now, with the support of this A and D in this T18, your answer for the problem is 75. I think everything is clear here, right? Can I move for the next problem? Yeah, right. See, have a look. I will give you one more problem right now here. For example, there is an arithmetic progression. Look at the problem. I have an arithmetic progression. For that arithmetic progression, pth term is given as Q, whereas qth term is given as P, and they are asking you to find nth term as well as P plus qth term for this arithmetic progression. I think it is clear to find, to discuss. Yeah, this is, we don't have this nth term as well as P plus Q. Just have a look how to find that nth term and P plus Q term. See, I have an arithmetic progression. Again, I don't know about the first term and the common difference. But now I need to find nth term as well as P plus Qth term for this arithmetic progression. See, they mentioned you that Pth term. See, for that, first of all, I am going to mention you the formula. Nth term is A plus n minus 1 into D. Right? So, to know about an arithmetic progression, to find the required terms of an arithmetic progression, you need to find the first term A as well as common difference D. For that, utilize this formula for these two relations Tp and Tq. Tp, this is the pth term. So this is nth term and this is pth term. You just replace n with p. Then you will get that A plus p minus 1 into D is equals to q. And Tq is equals to p. Then this is nothing but A plus q minus 1 into D is equals to p. Right? Pth term is q, qth term is p is given in such a way. Now to calculate A and D, do subtraction, minus, minus, minus. A and A will get cancelled. Here p minus 1 minus q minus 1. P minus 1 minus q minus of minus plus 1 of D is equals to q minus p. This difference. See, this minus 1 and plus 1 get cancelled. This is p minus q. This is q minus p. As a simplification, you left with D as minus 1. I think it is clear. Since D is minus 1, then you just utilize in any one of these relations to find A. I am moving with the first. So A plus P minus 1 is equals to Q. Have a look, this is A minus P plus 1 is equals to Q. And then on simplification you have that A is equals to Q plus P minus 1. So what I am going to conclude you is, if they gave you like Tp is equals to Tq and 2Q is equals to P, your common difference is minus 1 and your first term is P plus Q minus 1. But what you need actually the nth term. See, I mentioned you here the nth term as A plus n minus 1 into D. So this is equals to A is what? P plus Q minus 1 plus n minus 1 into minus 1. If you simplify, this is P plus Q minus 1 minus n plus 1. This minus 1 and plus 1 again get cancelled. You left with P plus Q minus n. See, this A plus n minus 1 into D is the general rule to find the nth term for any arithmetic progression. But for this specific problem in terms of P and Q, for this specific problem, nth term is P plus Q minus n. If that nth term is P plus Q minus 1, P and Q are constants as they given like this, whereas we are finding nth term, so this n is generated here. Use this to find the P plus Q term. So then your P plus Q term is nothing but replace that n with P plus Q. So P plus Q term is equals to P plus Q minus of P plus Q. So P plus Q minus of T plus Q is nothing but 0, right? So your P plus Q term is 0. Just have a look at the problem. See, once again I am going to explain you. There is an arithmetic progression in which the P term is Q, whereas Q term is P, and they are asking you to find the nth term as well as P plus Q term. To know about an arithmetic progression perfectly, we need to know the common difference as well as the first term. For that, make some relations between A and D like this, subtract them to get common difference as minus 1. Use this D in any one of these relations, then you have A as P plus Q minus 1. At the end you have P as well as D. Combine these two to find n as A plus n minus 1 into D. In this, if you replace A and D, your value of Tn is P plus Q minus n. And now, to find P plus Q, replace n with P plus Q and your answer is 0, and this is a problem related to the arithmetic progression. Right? See, based on this still you have many problems. I will give you one example how the problems are asking you. You need to look at this problem. I have an arithmetic progression. For this arithmetic progression, Tp is Tq, Tq is Tp, then Tp plus Q is 0. At the end we have P term is Q, Q term is P, P plus Q term is 0. Now I will have a problem. In an arithmetic progression, if they ask you T17 term is 23, D23 term is 17, then what you say about T40th term? What is your answer? Just think a while. 17th term is 23, 23rd term is 17. Then what you say about the 40th term? Right? Just think a while, and if you found it, just raise your hands.